Children, today we are going to learn about fructose. Fructose, otherwise, is another monosaccharide. That is, it is a simple sugar having the same molecular formula as glucose, as C6H12O6. It is a ketohexose. Ketohexose means having a keto carbon as well as hexose having 6 carbon atoms. It is levorotatory, that is, rotates the plane polarized light to left, that is in anti-clockwise direction. It is mainly present in fruits, so it is also called as fruit sugar. Now preparation. Fructose is obtained from sucrose. Sucrose formula C12H22O11. On treatment with dilute sulfuric acid or the enzyme invertase. We are getting C6H12O6 plus C6H12O6, that is glucose and fructose. Then fructose is separated by crystallization. This mixture having equal amount of glucose and fructose, so this is termed as invert sugar. Since they are having equal amount of glucose and fructose, they are called as invert sugar. This is the first preparation. Second preparation from inulin, that is hydrolysis of inulin, C6H12O5 N times inulin on hydrolysis. In the presence of an acidic medium, we are getting fructose, C6H12O6 N times. Now, we are going to learn the structure elucidation of fructose. Fructose is the sweetest of all known sugars. Then it is readily soluble in water. It has a rotation, that is levodotation. Then similar to glucose, it has many tests to verify the structure of ketose is correct or not. So the first test, elemental analysis, means elements carbon, hydrogen, oxygen present, and molecular weight determination of fructose shows that it has the molecular formula C6H12O6. This is the first test. Second test, fructose on reduced with corn HI and red phosphorus. It gives a mixture of two products. One is N-hexane having 6 carbon atoms, that is linearly arranged in a straight chain, plus one branched chain, that is 2-iodohexane. Formulas and you refer the book. 2-iodohexane indicates the presence of 6 carbon atoms in a straight chain. This is the major product and this is the minor product. Here indicates 6 carbon atoms, 6 carbon atoms in a linear arrangement, in a straight chain. Third one, fructose reacts with ammonium hydroxide to give oxime, then treated with hydrogen cyanide to give cyanohydrin. These reactions indicate the presence of carbonyl group, CO group. CO may be aldehyde or ketone or keto group. Any one present here. Fourth test, fructose reacts with acetic anhydride. Formula CH3CO, CH3COO. From acetic acid we are getting, it is acetic anhydride in the presence of pyridine to form pentaacetate. Pentaacetate, this shows the presence of 5 hydroxyl groups in a fructose molecule. Fifth test, fructose not oxidized by bromine water This indicates that that is absence of CH group, CH aldehyde group, absence. Because already we have learned here a carbonyl group is present. Carbonyl group may be an aldehyde or ketone. So from this test, since it is not oxidized by bromine water, it says that aldehyde group is absent. Next, sixth one, partial reduction of fructose with sodium amalgam and water produces two epimers. Epimers means having same molecular formula but at a particular asymmetric carbon. Asymmetric carbon means carbon bonded to 4 different groups. At a particular asymmetric carbon, there is a different configuration. That is fructose, formula CH2OH, C double bond O, then 4 carbon, last one CH2OH, OH, H, H, OH, H, OH, fructose on reduction, partial reduction with the sodium amalgam and water. We are getting 2 epimers. Epimers having same molecular formula only, but only one difference. 3, 4, 5, 6. Here also CH2OH, C, CH2OH. Here only the second carbon there is a difference. Here HOH, here OH, this only differs. Others and all same only. OH, H, OH, H, 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 OH, OH. OH, OH, H, H. These are called epimers. This is sorbitol. This one is mannitol. Both are epimers. This indicates, this confirms the presence of a keto group in carbon 2 position. Keto group in carbon 2 position. Sixth point. Seventh point, on oxidation with nitric acid, it gives 2 acids. One is glycolic acid, other one is tartaric acid, having smaller number of carbon atoms than in fructose. See, fructose, CH2OH, C double bond O, COH, H, CHOH, CHOH, CH2OH. On oxidation with corn nitric acid, assume that the bond breaks here. So from these 2 atoms we are getting CH2OH and this CO group oxidized to COOH group. This is glycolic acid having 2 carbon atom plus this one C oxidized to COOH, then CHOH, primary alcoholic group oxidized to acid group. 4 carbon atoms, that is tartaric acid. This shows that keto group present at carbon 2 in fructose structure, and primary alcoholic groups present in carbon 1 and carbon 6. Based upon these evidences, I taught 7 points. 7 points. From here I taught 7 points. From these 7 points, the structure of fructose can be written as CH2OH, C double bond O, that is keto group in the second carbon, COH, CH, OH, CH2OH. These are asymmetric carbon. Three asymmetric carbon. Asymmetric carbon means carbon having 4 different groups. This is called as D plus fructose structure. Fructose. So based upon this structure of fructose, based upon the 7 tests, we have arrived this structure. Now this fructose, like glucose, they also forms a cyclic structure in the form of furan. Furan is a 5-membered ring, hence it is called furanose form. Furanose form, when fructose is a component that is present in sucrose, it is usually occurs as furanose form. There are, first it's this is the open chain structure, CH2OH, CO, COH, HOH, HOH, CH2. This is D-fructose. This is the open chain form. Now this open chain can be drawn in ring form. How it can drawn in ring form? Closed structure. It is 5-membered ring we are getting. See how I am drawing, you see. I will show the structure. Now this this bond can be shifted like this. So getting a negative sign. To satisfy this negative sign, carbon, 5th carbon, 1, 2, 3, 4, 5. This 5th carbon, this hydrogen is shifted here. So based upon that, based upon this, we are getting the structure like this. See, carbon, this carbon, here OH. Since this H shifted here OH, and this one comes this side, CH2OH, the next CHOH, next CHOH, CH, this O, one O is there, let me keep it. Then this CH2OH comes this side, then this O getting bonded like this. This also called as isomers. One more isomers here, OH present in a right side here. Now this also can be changed only this form. See, OH, CH2OH, COH, H, CHOH, CH2OH, one O connecting the both. Since this OH present in the left side, this is called as beta D fructose. Beta D fructose. This OH present on the right side, that is called alpha D fructose. Alpha D fructose, beta D fructose. So a cyclic form can be formed, see, like furanose. It's a 5-membered ring, see. Only this portion is going to be changed. This is the first carbon, CH2OH. This is alpha D. Alpha D I am drawing. CH2OH. Then OH coming at the bottom. This OH. Then next one, OH, H, then H, OH, OH, H, HOH, then 6th carbon, CH2OH, this is the 5th carbon, H, 5th carbon this one, then H, Same structure only for this. Only difference is this CH2OH comes at the below, OH comes at the top. That's only different. Others all same only. CH2OH, HOH, HOH. Here OH, CH2OH. This is beta D, fructofuranose. Why I am telling furanose? Because it takes the shape of the furon. Already have learned in 11th standard, furon structure, 5-membered ring, furanose. This is beta D fructofuranose. This is alpha D fructofuranose. Everything clearly given in book page number 244, 245, 246. If you can't understand, once more repeatedly go through the video and you can notice.